Good evening again to everyone who has already joined us. I think we can proceed with the meeting, and I hope that the rest of the folks who want to join us today will join as soon as possible. Yeah, so basically today is our fourth meeting of the Bioinformatics Club, and I remind you that this is the set of the meetings which is dedicated to the discussion of sort of best practices for data analysis, at least this first session. And today our topic is downstream data analysis, which will be focusing on mostly on dealing with R Markdown and Jupyter notebooks, but not only. I think we'll touch upon the issue of generally using R or Python. And also, as usual, at least as last time, we have a broad range of people who are here with us in the experts. So first, hello to Roman Chernyaczek from JetBrains Research. Roma, do you hear us?
Yes, hi guys.
Mm-hmm.
Yes, hi everyone.
Mm-hmm. Yeah, we hear you. That's perfect. Also from JetBrains Research here, Kosta Zaitsev. Kosta, are you here?
Yeah. Hi everyone. Yeah.
Nice, great, thank you. Yeah, we also have Alona Kizenko for the second time. Hi, Alona.
Hello, everyone.
Great. Yeah, and we also should have, I'm not sure whether the people have already joined us or not, Gennady Zakharov from EPAM Systems. Gena, are you here or not? Okay, it seems not yet. And we also will Alexander Predeus from the Sanger Institute will also join us in the next minutes. Yeah, so we hope that there will be like more people with us today. Yeah. Okay, good. So having said that, I think we can start with the substance part. As usual, I have sent the link to the form in the chat. I think I can repeat it once again because I'm not sure whether everyone sees them. I think that the chat should be continuous, so it should basically be visible to everyone who joins, but I'm not sure. So I just repeat the link to the form again, and you can also find a link to the form in the email because we've sent it, I think, half an hour before the meeting started. Just a usual form with several questions regarding like what people use and what people don't use, and we'll turn to the results in a couple of minutes. Yeah, so as a short introduction, I think I should introduce the substance of what we're going to be talking about today. So today we are discussing with the downstream analysis, and that's a very, I think, debatable separation of the analysis into upstream and downstream. But basically, the main idea here is that the upstream analysis is all sorts of pre-processing of high throughput data when you basically go from the raw data, be it sequencing data or some sort of like mass spectrometry, etc., or whatever the data set you have, to some numeric, usually data set, which you could explore using various tools, visualize, do some statistics, and basically test some hypothesis, which you would like to do as basically the substance of your research. And when it comes to this final part, yeah, there's a lot of like variability of how you can do this, what tools you can use, but generally, in terms of the programming languages, there are two basic options which are commonly used, and this is naturally R and Python, which are the two horsemen of the apocalypse, so to say. Yeah, and I think that like many people use both R and Python. Some people prefer to stick with one of these for this or that reason. But of course, both R and Python have a very great infrastructure for genomics, bioinformatics, so not only genomics, but essentially for analysis of any omics data sets. A lot of libraries which are prepared, which are designed by experts, by researchers in these fields. And of course, for R, there is Bioconductor, which is a great repository of all sorts of packages for essentially all sorts of purposes with regard to bioinformatic data analysis, be it again genomics, transcriptome analysis, single-cell RNA-seq, whatever. And of course, Python is no exception. It also has a wide variety of different packages which can be used for essentially all or nearly all of the same things which R can be used for. So there is naturally like a BioPython library, which is I think quite often used for dealing with all sorts of common sequencing data related formats. And of course, with last time we've discussed Conda and dealing with virtual environments. Of course, Conda as a package manager has a channel called Bioconda, which includes essentially like most of the software and packages as well, which you can use for various sorts of data processing in bioinformatics. So like both R and Python essentially can be used more or less interchangeably. There are a few, I think, solutions which are exclusively available in Python, which basically you can like sorts of data analysis, which you cannot do with R, or vice versa, which you cannot do with Python. It's a very, very, I think, marginal cases, and most of the time there are alternatives for both languages. Yeah. So and today, that's basically what we're going to discuss. So we'll discuss what to choose, what do people prefer for this or that kind of analysis, and how to make the analysis with either R or Python reproducible. And having said that, I think we can start to look at the results of our questionnaire. As usual, again, I remind everyone who's joined us that there is a link to this form. It should be visible for everyone in the Zoom chat. If not, then you can find it in your mailbox because the mail was sent out, I think, half an hour prior to starting this meeting. Yeah. And as usual, the first question is the level of experience. And also, as usual, which is quite nice to see, we have like 50-50 separation into experienced folks and folks who are more entry-level bioinformaticians, which is nice to see this demographics and to get the feedback from both of these groups. And the first question, again, in this short questionnaire was which of the two languages, essentially R or Python, do you more commonly use in your practice? And here we have a slight preference towards R. I think it's not like a dominance, of course, but yeah, I think quite a visible preference towards R among people here in the audience who have responded to the form. And I think that's a good starting point to start the discussion. So basically, my first question to everyone who's here with us and the experts in the audience. So basically, which of the two do you more commonly use, R or Python? And the other question is, which one do you prefer? And do you think like what are the perspectives? So basically, now I think there was a lot of talk about R is going to die essentially slowly in the next years. But I think not all people agree with this statement. So it would be nice to hear your opinions on that. So let's start with Lana for today. So what's your choice and what's your opinion on basically R versus Python debate?
With me, right?
Mm-hmm.
Okay.
Yeah.
Here I voted for our team. I'm in Team R currently, but it really depends. If you ask me like a year ago, it would be Team Python, because it really depends on the project that I'm working on. When I did more genomics and like I worked with transposable elements, and this was really a huge amount of data, and I preferred Python for this. But now I work more with expression data, with phylogenetic trees, and for this in R are really good libraries. So for now I'm in R team, and I think like like few years ago when I was really obsessed with R, but then I learned Matplotlib and Seaborn, and then I was like, why do I even use R? Because you can just learn one language and then you do everything in Python. But I think in general, R is a very good language for people who don't want to learn a lot by informatics, who want to like start with something and to analyze their data. They don't want to, dig deep in the language, because it's a very high level language and it's very, very human readable. And I think R is a great language. So I don't think it will die. I mean, not now, not in a few years, maybe at some point, but I hope it will not. Yeah, I think it really depends on your current project. If you're writing a pipeline, of course you use Python. If you're analyzing data and really wanna, I don't know, customize your plots and do like some, I don't know, fancy phylogenetic trees, I would prefer R for this.
Okay, yeah, thank you so much. Let's move to more like computational side people. So, Kostya, what do you think on that?
I think it's kind of the same. I'm definitely R team here. It's mostly due to the fact that I actually also do a lot of gene expression, and historically, many gene expression packages and many differential expression packages were developed in R. And there are been slight improvements in that regard in Python in recent days, but still not enough effort made to move many essential things from R to Python. It's kind of weird for me to hear people praising Matplotlib, because I think that Matplotlib is a garbage. Complete garbage bin should be like rewritten from very beginning. And ggplot is better than Matplotlib can ever be. I don't know. So like, for me, it's insane to hear this. Like, I definitely understand that R is for me personally, I prefer Python as a language more. And I think R is not a very well-designed language. But in terms of usability, in gene expression, R is just like have much more use cases, and ggplot is definitely better than Matplotlib. And I don't know, so yeah, this is how it happened for me. So mostly because of the gene expression analysis being just more represented in R than Python, yeah.
Okay, yeah, thank you. So, Roma, what's your take on this issue?
And I'm from Python minority. So I agree that there are lots of good tools, especially used in bioinformatics, which are available only for R. And that's why I'm sure that R will not die in next many years. But for my research, I need to work with a large amount of data, and initially R was slow for me, so I switched to Python. Maybe there are some workarounds, but I also like Python syntax much more. And that's why I'm using both, but mostly R. Oh, but mostly Python.
Okay, thank you. Diana, are you with us? Do you have anything to add to this? What team are you in? I think that I've seen Gennady joining us some time ago.
Oh, I'm
yeah.
here. Just
Yeah,
got
great.
some time to unmute my microphone. So here, what to say? I believe that this is heavy dependent on the task and the library what you are going to use. But probably due to my nature, due to my work, I am in a Python team, because Python was my first. Second general language, and I believe that's one thing, that R has really very good design libraries, and I haven't in fact much experience with R, but what I can say. But Python, I believe, has a better design as the language itself. And what was important for me that, of course, I had to use some do some magic with pandas and matplotlib when you don't completely understand how it works, but you try to Google. And what was important for me that Python, it was always pretty informative. It was easy to find what's going wrong. I believe the pandas is some cases with pandas is the only one exclusion from this rule. And I don't know, probably the situation became better now, but as for R, sometimes, in my case, R even don't put the line number with error. That's something unconvertible types, and I have spent quite a lot of time to understand what in fact is wrong. So that's the reason why, of course, I can use R, but if I have the ability to choose, and there are libraries with comparable functionality, I prefer Python.
Okay. Yeah, thank you. I think that that's many people mentioned that the libraries are a big issue because yeah, with R there is a lot of very useful things, and I think that they are slowly getting re-implemented in Python. At least that was one of the cases when I had an idea and I thought that would be a nice idea to re-implement like dseek2 in Python, which is a differential expression package. And then I like Googled that and found out that was I think the beginning of 2023 someone has already done it. So there is like a PyDseek2 package now for Python, which essentially has the same functions. At least they have a pre-printed bioarchive. I'm not sure whether it's
one more thing. I believe that probably we can giant re-implementing all the R packages in Python and won't be of the half of this way. So believe the better idea is to make some general approach, probably the ability to call R packages from Python. And I believe that will be the very drastic improvement. Of course, you can do the opposite way and call Python functions from R. That I believe also could be possible.
I think actually that there are libraries for, at least there's RPy library, which does some sort of, I'm not very like deep into it. I think I've seen and used it once many years ago. Yeah, but basically there are some solutions which allow you to do this and essentially mix the two in the notebboks, which will, I think, come to talk about in a few minutes.
I mean, in R, there's definitely reticulate. And reticulate can be used to actually call Python functions and Python APIs from R code for sure. Yeah.
Okay, that's nice. Yeah, I've never used it myself, but that's nice. Yeah. Yeah. Regarding, I think I have one thing more to add regarding the visualization. So basically, yeah, here I am more in the ggplot team with regards to the data visualization. I know that there are quite a few people who prefer Seaborn to other like visualization options and to ggplot. I personally am like, for me, the syntax and the idea of ggplot is better. I think it's easier to comprehend, and this I think the same is true for our data frames versus pandas data frames in some way. And I think that has to do something to do with the fact that R was basically designed not as a 100% like programming language for programming people, but mostly for people who are not that experienced in programming. And that's the reason why it has many things which may seem weird to computer scientists, but seem quite natural for people who are not from the computer science background. Yeah, but I definitely prefer ggplot to Seaborn. I think that raw matplotlib, maybe maybe I'm mistaken, but in my opinion, raw matplotlib is worse compared to Seaborn. Seaborn has many like simplified plotting compared to raw matplotlib, but I'm not sure. Maybe someone who is more experienced with Python visualization can comment on that. Maybe Alona has something to add. So whether you use like matplotlib as it is or Seaborn.
I used Seaborn, but not for such a long time, because I switched to ggplot back because it was just so intuitive. And Seaborn and matplotlib, they are sometimes, like if you first learn matplotlib and Seaborn, it's fine. But if you first learn ggplot, it's very counterintuitive to then kind of use these two packages. So I tried a bit because I was trying to choose between R and Python at some point in my life. And I could not. I mean, I did something like in Jupyter, and I used matplotlib, and I used mostly Seaborn, but then I just switched back because it seemed too hard to change.
Thank you.
I
Okay.
will also mention Plotly library because it's really worth mentioning. I really like it compared to Seaborn because it allows you to make interactive plots and export them as HTML. So it's quite convenient. And I'm not sure, as far as I know, Plotly is also could be used with R, but I haven't tried it yet, and I'm not sure whether folks use it or not.
I mean, in R, kind of rarely. I think ggplot is done well enough to rarely need Plotly as a kind of substitute. I used it several times when you needed to have a lot of like interactive plots in JavaScript though. So like whenever you write something in the like client side for web, for example, and you don't want to do something like for heavy data set, something like Shiny applications, especially when you have to load a lot of stuff in memory, Plotly does wonders in web. So like whenever I have to plot something in web, especially like large plots for like single cell applications, Plotly just does some magic in web, that's for sure. But in R, ggplot does fine. Yeah.
I like Plotly for volcano plots when you can annotate each point, and you can maybe you could render maybe top of points, but their annotations usually intersect, and it's not very convenient to see.
Yeah, I think I agree on volcano plot, especially because you can just like mouse over the gene you're kind of trying to look at and like see gene names as well. So yeah, interactive plots are definitely something. Yeah, Plotly definitely allows you to have some interactivity that ggplot might not for sure. Yeah.
I think in Python there is a package called bokeh or something like this. I have seen it only once integrated into another library for genome-wide association studies, which is called Hail. And then they have the like interactive plotting with bokeh. At first I am afraid to be mistaken whether it's bokeh or botech, but it's something like this. I think it's BOKEH or something like this. Yeah, and it does pretty much things similar to Plotly. Yeah, I think it's expectedly harder to customize, but generally it is an alternative for Jupyter at least. Yeah. But I agree with the idea that Plotly is nice for this kind of data types when you have to plot a lot of points and you want to see each point like interactively, or another use case which I myself found particularly useful when you have a large like heat map and it is hard to understand which like square comes from which like intersection of rows and columns. In this case, also, if you have an interactive heat map and you can basically just hover over the particular square on the heat map and see basically what are the row and column ID in this case. This is also pretty useful. So I definitely agree with the interactive plots are nice for this kind of exploratory analysis. Not for publication probably, unless you are publishing something with web applications, but yeah, generally for the exploratory kind of thing, that's really nice. Okay, I think we can move on. the discussion. So having said these things about the general R versus Python, I think we can move on to the idea, the main part about the reproducibility analysis of this too. So basically, yeah, both R and Python essentially, yeah, of course, are programming languages, and you can write scripts in both R and Python. And then you can execute them. But of course, there is a need to do it first in a more interactive way to be able to execute several lines of a large piece of code, and to see like the images embedded into what you are doing, see them right away. And also to be able to comment and add some text descriptions, etc. And this is when the R Markdown and Jupyter come in. So basically, these two things, yeah, R Markdown and Jupyter allow you to create basically this mixture of code and text and images, and execute these in sort of in an interactive way. The Jupyter allows this natively, R Markdown when combined with a particular IDE, but we'll, I think, come to this issue a little bit later. Yeah, and again, the nice thing is that you can do all of the things in once, write code, execute code, look at the results. And also, both R Markdown and Jupyter allow you to basically export your entire like project into some sort of like common format which people may use. HTML files as a default, but also you can of course export to PDF, and R Markdown supports docx export. I'm not sure with Jupyter whether it does or not. But for people who like exporting to docs, that's probably a thing. I've never used personally any time export like or knitting of Markdown documents to doc format, but at least it's possible. Yeah, and generally, yeah, before we move on to the discussion, I think I can if there are any people in the audience who've never seen R Markdown or Jupyter notebooks, I may give you like a very short idea of what it looks like. So basically, I have a couple of examples right here with me. These are not not the best examples, I should say. So that's some of our projects. It's not, again, the best way to organize this kind of thing, but generally that's what the results of like knitting R Markdown to HTML looks like. So when you write the Markdown file and then compile it to HTML, basically you may have some sort of like textual description of things embedded here. You have the chunks of code which may be shown or may be hidden for some technical things. And the outputs which are shown when you execute a particular line of code are also embedded in here, also can be hidden if you want to. And naturally the plots are also here, which is very convenient. So you basically can see the textual description, you can see code, and you can see the plots all essentially in a single document. So that's like one example of what the output from an R Markdown file may look like. With Jupyter, essentially, that's pretty similar. Again, you may have plots and code and everything embedded into a single page. So that's again a snippet of the large Jupyter notebook which we've had for some sort of analysis. And basically you see the same, that there are the chunks of code in the cells, and some output of this code which are shown in this place under basically each chunk. And you may have as well embedded the plots. That's basically what the plots look like. We have the Python data visualization. I think there are substantially less pretty compared to what ggplot does. But yeah, generally that's what the Jupyter notebook might look like. Again, not the best example of what it is, but again, the same functionality, code, output of this code, some textual descriptions of what you do, which you may use add using the same like Markdown format. That's essentially what it allows you to do. Yeah, and I think here we may switch to the next question in the form in which I asked basically what's the usual practice of the people in the audience with regard to storing R code or Python code. And basically, there were 5 options here. So first option was I always use scripts and I never use Markdown for any purpose. Then there was I always use Markdown for all purposes. I think that was this purple sector over here. And then there were options like I sometimes use both Markdown and Jupyter notebooks, but I do scripts most of the time, keep in plain scripts, both R and Python. And then there are two options that like for R, I use Markdown, but for Python, I usually keep everything in scripts, and vice versa. For Python, I use Jupyter, and for R, I usually keep everything in plain scripts. And I think that this is like the fascinating result. So basically, we have almost all of the audience is like separated into equal pieces. I think only the people who prefer to do everything in Markdown notebooks are in the minority, and that would be very nice to hear the people to hear the arguments for this particular approach to things. But yeah, in general, I think that there's pretty much the same amount of people who never use anything for like Markdown, Jupyter. There are that use sometimes either Markdown for R or Jupyter for Python, and people who use sometimes this and that, but keep majority of things in scripts. Yeah, I think that's a nice starting point for the discussion. So my first question regarding this is basically at what point in time do you basically switch from like a plain script to Markdown and Jupyter? I think the question is a little bit different for R and Python, because yeah, naturally for R you have I think like more native line by line execution, but that's debatable. But generally, yeah, it would be nice to hear the opinions of all of the people who've responded basically in this or that way. So yeah, let's go this in the same order. So Alona, in which group are you here, and basically what's your attitude towards when you should like stop writing a script and start writing a Markdown file or a notebook?
I'm in a green team, so I mostly use Markdown, but keep Python as plain scripts. I can elaborate.
Yeah, please.
Don't judge me for plain scripts, because so I use Python mainly to kind of parse files. I usually work with like faster files that I need to, I don't know, like change their names. I need to do some things with these like multi-faster files. Or I write like a pipeline already, or I use something. So I usually, my Python scripts are like, either they are like in sysarc, so I just put the files to the like provide files to the script, or I use argparse. So they're not kind of the secondary analysis, so they are primary. That's why all of them are in the plain scripts, like almost all of them. And I use R Markdown. I actually use not Markdown, I use Quarto. This is like the next level of Markdown. I can share if you want, I can send in the chat. I usually have, for each project, I have R project. And then there I have like the data folder, like the folder with scripts, like with plain scripts. And at some point, if I realize that things that I write in a plain script are too much and I have to switch to Markdown, and it usually happens like, I don't know, after like 20-30 lines of code, and I realize that actually it's not just a plain script, I have to switch to Markdown, then I switch to this Quarto document. It has more features than basically the Markdown, but it has more features like, I don't know, fancy features like folding the code, like, I don't know, doing the reference list, like the literature, because I usually provide these documents for people who are not familiar with data analysis, so to biologists, and they really like if I cite something, if I put like more pictures in the past, so it's like a report. So yeah, so most of it, yeah, in Markdown.
Yeah, thank you. That's a nice thing that you remember Quarto. I think we should discuss it just a little bit later. And if in the meantime, while we hear to other people on this particular question, I would be very I would appreciate if you could prepare, if you have some example which you could basically screen share instead of me of something in Quarto. I think that would be quite useful to see what it looks like, because I don't have a possibility to show anything, and that would be nice if you could demonstrate something. Again,
I have a look now.
Yeah, I will ask you to do so when we switch to discussing like extensions to both Markdown and Jupyter. Yeah. Okay, yeah, let's move on with this topic. So yeah, regarding the scripts versus notebooks, and when is the right time to switch from scripts to notebooks? Costa, so do you have any thoughts on
so like I actually think it's almost the same for me. So I also use Quarto. I use mostly the reports for R, and I mostly write scripts for Python. It's a bit for different reasons, because I think I learned Python before I was doing data science and any bioinformatics in general. So like I don't know, let's say I just used language much more differently. So like I'm used to like imperative style of like writing code in Python more than line by line in R. So like, yeah, I used to be programming in Python a lot. So I just like, it's just a matter of habit for me to mostly write in scripts. Then I switched to R and became a bioinformatician, and now I mostly do R analysis using reports. I also use Quarto. Quarto is amazing. Allows a lot of extra features on top, simplifies a lot of PDF generation, because most of the LaTeX features are included as well, and so on. No, so like I think angle is very similar to Alena's. Yeah.
Great, thank you. I think it would be nice if you also could share some examples of what you do.
I think actually one more thing that I wanted to mention is like I also prepare a lot of teaching materials and presentations, and Quarto is also quite amazing at that as well, because like it's not only reports for me, it's also basically I have the code that I can later share with the students, and I know the code is working because the code was used to generate the slides. So it kind of have some small, let's say, guarantee that the code actually does something. So like, and then you can just scrap all the code from Quarto file or RMZ file to just plain R script and share it with these students. So like for me, like generating presentations like as a teaching material is also very useful thing. So yeah.
Great. Yeah. Then again, I would appreciate it if you could show especially this last part regarding the like slides and teaching materials.
Yeah, so sure. I can share slides. Slides are public anyway. Yeah.
Okay. So then I'll ask you to do this a little bit later. So let's finish with this question. Okay. Let's move on to other people in the experts. So Roma, what's your take on that? What's your attitude towards notebooks versus scripts?
So before answering, I have a question to R guys. So basically Jupyter is not only about Python, it allows you to use different languages, for example, R and Kotlin and maybe something else. And I'm just interested, what is your attitude to using R core for Jupyter? Have you tried it? Is it convenient or not?
So like for me, Quarto also has support for Python, like Julia and other stuff. So like I just never, it's like at some point that I switched to Quarto, then I just don't have a need to switch to Jupyter at some point, because like it also has Python support. So for me, it's just much easier to use Quarto with sometimes different engines behind Quarto. So like you can say, hey, I want to use R, I want to use knitr, or hey, I want to actually compile compile Python kind of presentation and use Jupyter as a backend for Quarto. So for me, just never really crossed my mind at some point, like to switch to Jupyter. Yeah.
Okay. Yeah, thank you. So, I think Roma hasn't finished his take on the matter. Yeah.
Yes. So I voted for orange answer. So I mostly use Jupyter notebooks for code visualization, for some data analysis, and as for extraction of scripts, sometimes when I want to make some kind of tool to reuse it in pipelines, or maybe to reuse it across notebooks, I export this as some reasonable Python script. As for R scripts, I usually use R only to launch some tools and to get some result. And this result, then I visualize only in Jupyter. That's why since I don't need R Markdown for my R scripts.
Okay, yeah, thank you. Regarding the usage of R core in Jupyter, I personally, I think, never did it, but my students have done so, and I think that worked quite smoothly. So at least I didn't hear any complaints regarding this. Yeah. I think that we also have Alex Produce who has joined us. So Alex, if you could hear us, could you please share like your take on basically scripts versus notebooks, whether everything should be in notebooks or not? Like, what's your attitude? What's your preferred way to organize your code?
I have a funny take actually. I can never, so like when you work from home or whatever, when you don't have an external monitor that's really high resolution, it's nearly impossible to use RStudio, right? So that's when I use R kernel and actual Jupyter notebooks, because they're like one page and it's just convenient to get from regular like laptop on a laptop screen. But yeah, so I think the place I'm at, everybody who's doing downstream is pretty much 90-something% Python, because with the single cell and there's a lot of like huge data sets now. And the higher the number of cells, the more dramatic becomes the engineering differences. That's like Seurat versus ScanPy. So everybody's mostly like in Python-based ecosystem. So Jupyter is like a natural thing for it. And there is actually, I forgot what's the name of a guy, but if you Google I hate Python notebooks in YouTube, there's a guy who basically lists almost every single problem there is, like what not to do in terms of like notebook organization. He lists few problems that sort of like pertinent to reproducibility. Like what can you do wrong in terms of like sort of organizing your notebooks? If you don't do that, a notebook should be pretty great. In terms of sharing, reproducibility, and everything else. I personally think our notebooks are abhorrent to look at. Like I can't single out Markdown from code.
You mean in the editor mode, yeah?
Yeah, in the editor mode. So if you work in RStudio, whatever, it's really hard. So my R code is always organized, just code plus comments, and that's it. Which I don't think makes a huge difference for R particular, like if you're sort of working in actual IDE, which is RStudio, that's more convenient anyway. It's just, yeah. There might be some little technical things that are more convenient in a notebook, but I'm not sure. We made a big course for like, which I helped reorganize a big single cell course that's organized as a Git book. So like all the individual pages there are like R Markdown pages, so that's good. Like, so yeah, if you do something like that, that's good, because then you do, yeah, knit it into a like HTML or PDF and it works nice. it's just for that, but it's probably not the case for everyday work, right? For work organization. Yeah, that's I guess that's all I have. Like, if you work in a bigger environment, like if there's more than like 3 of you, invest into sort of common repository which would serve as a starting point for your notebooks, because otherwise, if it starts from C, my drive, whatever, my Google Drive, it's not. Yeah, and yeah, I guess that's it.
Okay, thank you. I think I could a little short question regarding the you say that the Python is like 90+% like for the single cell. I asked this question to the audience, like whether R is going to die in the near future. So what do you think? Is R definitely going to die or not?
No, there's there's way more tools in R, right? And like I think it's just a problem. Like single cell has 3 ecosystems that I know of, maybe 4 if you count Monocle. There's a single cell experiment, which is bioconductor, is logically organized and fairly tidy, but there's barely any packages there. There's Surat, which is lots of people write it. So like everything, the newest things appear in Surat the fastest. And then there's ScanPy, which is you have like professional, I think, coders organizing it and managing it like you would do with a big software product. So it's like, it's way better written, but it's very slow to adapt any new feature. So that's the difference there, right? So we're kind of stuck because like the amount of RAM, the amount of things you work with, you have to use Python. Otherwise, it just won't work unless you have like a terabyte of RAM to yourself. But Surat is also really, really good for like smaller data sets, right? Like every little small thing, yeah, you just run it and it's fine. And honestly, I don't like, it probably depends who learned what first, but I think overall consensus is that like tidyverse and ggplot way of like thinking and plotting of things for visualization is pretty great. So some people don't like it. I still like, I work with a guy who's super productive, wrote a bunch of papers and does everything in base R, everything strictly, right? But yeah, if you're good, you're good. What can I say? If you're a maniac, you're a maniac. Yeah, so ggplot is good. So like anything like that's based on ggplot is also customizable. You can work quite a lot of things in there. So that's definitely not going to die. Too many things are done there.
Great, thank you for this opinion. So we have, I think, Gena left, who's not yet commented on this matter like of notebooks versus scripts. So Gena, what's your experience? Okay. Yeah, is Gena still with us? I wonder.
Yeah, I'm
Great.
still here, but I had not so good connection. So probably could you repeat the question?
Yeah. So my question is, so what's
here.
what's basically your take on whether like you use notebooks in R or like R Markdown or Jupyter?
Understand. So I believe that my experience is kind of biased because I usually use for some small actions plain Python scripts, but sometimes use the Jupyter Markdown. But probably the main reason of this is that because when I started programming and when I used the Python scripts, there was no Jupyter and there was no Seaborn. So I used the plain scripts with matplotlib and output to files. Now I slightly changing my preferences, but still I use plain scripts more often than Markdowns. Markdowns probably mostly for investigation, and when I started usually when I started some don't know how can call the production scripts, which I really use to process my data, I prefer to make it a plain one.
Okay. Yeah. Thank you. Yeah, I think I can also comment my opinion on this matter. Yeah, so here I think in the red category, yeah, which basically is that I basically use both R Markdown and Jupyter. I completely agree with the fact that R Markdown editor is garbage at least in our studio. Yeah, but unfortunately, it is what it is. I definitely like Jupyter for all sorts of analysis, which involve like exploratory analysis. Of course, I keep something in scripts, which is not for basically exploratory analysis, but it's essentially for parsing and like just simple execution. But naturally, yeah, I prefer Jupyter notebooks whenever it's possible, and I don't like Markdown pretty much, but I do try to use it for things which require documentation in terms of like description, etc. Because comments in the code may get like too extensive at some point in time, so you have to switch to using Markdown for documentation. Yeah, so that's my take on that. And now let's move to the next issue, which is the question of what tools do people use. I think we could have already some people who have mentioned Quarto, and I will give floor to both Kostya and Elena in a minute. But before we move, I think I should say a couple of words like in terms of the introduction. So again, we have both like Markdown and R Markdown and Jupyter notebooks. Jupyter notebooks have basically the default Jupyter editor, which is quite nice and does most of the things quite well, especially with certain like package extensions. But naturally, there are so-called IDEs, like developer environments, for both like R. I think RStudio here is the most popular, and I think the best of the alternatives. And of course, Jupyter notebooks can be used from within different IDEs. So, for example, from like VS Code, you can use the Jupyter notebooks from them. You can use specialized software like JetBrains DataSpell, for example, which will like basically provide nice functionalities on top of the default Jupyter or like default R Markdown. DataSpell, I think, has some functionality regarding Markdown files in R. Yeah, and in terms of our questionnaire, I think here most of the people naturally use RStudio, which I think is quite expected, given that it's really outcompetes everybody in terms of the ease of use for R code. Yeah, but we have quite a lot of people who are using the different alternatives. So I think that there's quite a lot of people who use PyCharm and DataSpell. Not DataSpell, but PyCharm, yeah. And there are quite a lot of people who use VS Code, and yes, we have people who use Quarto. Here, I'd like to give word to. I think we'll start with Kostya. So Kostya, if you could basically like show you what it looks like for you, and then we'll switch to Elena and ask her to share her basic experience with using Quarto.
So I'll kind of try to explain to people what it does. I think it's like more publishing tools on top of RMD and Jupyter. So like you can actually use it with Neater for R, you can use it with Jupyter for Python, you can use it with Julia, you can use it with Observable GS. It's mostly about publishing and authoring reports and presentations. So it comes with Pandoc installed within it, which is super helpful because building Pandoc yourself is a painful process because it's like written in Haskell for quite some time ago. And I think it just like kind of adds a lot of extra features on top. You can use it within Jupyter, you can use it with RStudio, and you kind of write the same way you would do with R Markdown, but in the end, you kind of get a bit of a different result and a bit more features for what you get. I can only show you some of the presentations that I did with it, because other stuff right now I cannot show you RStudio because of the privacy issues. But I can definitely show some of the public presentations that I have nearby. Give me a second. So yeah, I think I can try to show. Okay, give me a second. Share screen. Share. Yeah, so this is basically some of the public presentations that I was given during master's course at my university. So this is basically like slides, and you also have a lot of supports, like a lot of support for the code, showing the code outputs, writing stuff, showing plots, like showing different kinds of visualizations as well, trying to make sure that like students understand what to look for, how to visualize stuff, and how to basically, you can just like slowly go like line by line, showing what the outputs, what the inputs are, trying to focus their attention to what to look out for when you do the analysis. And as a teaching tool for me, especially, I think R Markdown and later in my life, Quarto was very, very useful, because I could just like put all the code I need in one file, basically compile it, and it's reproducible. The code is in there. So like most of the codes that generate, like most of the images are generated from the code. So like, it's not like I'm trying to put the picture of something into PowerPoint and so on. And for me, yeah, especially like as a teaching tool, R Markdown and Quarto were very, very helpful. And I think that's all for Quarto from me. I think Aliona will show you a bit more. There's also like visual regime in our studio, and I hope that Aliona gonna show it because I think some of the issues that Alex Predov and also that Yura raised are addressed with visual regime of Quarto in our studio. It looks just, there is more clarity between the code and the pure text. Yeah.
Great, thank you. Yeah, so then Alona, please, the floor is yours for the Gmail. Thank you.
Yes, I can. Yeah. I guess you can see, I know you can see the already the knitted document, right?
Yeah, probably.
Or like you don't, do you see something? Do you see my R studio?
Yeah, so now we see our studio as well.
Yeah, great. So this is how it looks like. I did like a small 2-month project. And in the visual regime, I think, like for me personally, the R Markdown is also fine. I can distinguish between code and non-code. But in Quarto, it's a bit more clear because it has, I guess, this like frames, and it has this, like dashes. And there you can just like put pictures, and they're already depicted in the document. And there you have a code. I have a code for libraries, like a chunk, sorry. And then I do some description, and there is a chunk, like again, the line of code. And yeah, that's how it looks like. Like it's a bit more clear. And if you, for example, if you switch to source, yeah, it's going to be like this. So then it's not so clear. I guess it looks a bit like a ordinary Markdown. And if you run this all and render in a document, you can see the Markdown right now, because I cannot see what I'm sharing.
You're sharing the tab from the browser.
Yeah, the tab, yeah.
The report, yeah. Yeah,
the report. So this is how report looks like. And what I like that you can really for example, you can show all code, or you can hide all code. And here is the contents table. You can easily switch between the analysis steps. And then you can also put the pictures here. You can do the description. And I think it looks quite pretty. And yeah, and you even can do for example, you can put a picture, figures from the papers, and you can put links to these papers. And then you can do also the references. I think it's just very, very, I don't know, user friendly. And they have a very good manual, as I think. Yeah.
Great. Yeah. So in terms of the references, so do the references do you input them manually or source from within, or is it from Mendeley or reference manager? So basically, where do these come from?
Oh, a good question. I don't remember. I think I think you just put them manually. Yeah, I think you, yeah, true. You put them manually. So there's also like a siting manager inside, as far as I remember, and you just put all the things. And yeah, and then you just click one button and then it gives the references at the end of the document.
You can clearly use also like bib file extensions with like from other citation managers. So like you have to like, the thing I really love about Quarto is that it kind of comes with pandoc inside pre-installed. So like it has a lot of like LaTeX and like pandoc features, and kind of just work for you. You don't have to, it's much less pain in the ass to install than to actually have LaTeX installation going on your laptop. So like citations managers are just working out of the box, and many other features for just like authoring and doing like I would say scientifically better reports just working for you. Yeah.
Yeah, that was really nice. Yeah, thanks to both of you for sharing basically what it looks like. Yeah.
So I wanted to ask, sorry, ask a
Sure.
quick question. This is, so it says like download, I clicked on your link and it says like it's a command line interface, right? So can I install it on like, we have like a Jupyter Hub. I usually work in an instance just in the browser. So that would be just a package installed there, and then you have to configure it through like RStudio.
So like with RStudio, it's kind of simple. You just like install it on your machine, and then usually it knows where R is installed. So like RStudio just catching it up and shows it in the UI. But it's mostly because I think it comes from POSIT, which is previously called RStudio and R team. So basically they are the same people. So that's why it comes with our supports. Like I'm not sure how it's working with the Jupyter exactly, because I never used it with the Jupyter.
Yeah.
But I think it should be somewhat out of the box as well. So like once you install it in your machine, if you just like show the way for the Jupyter Hub to the Quarto command line, I think you should be able to compile the QMD files the same way you compile Jupyter files. Yeah. So basically just a file extension and like a terminal, but you can link. Yeah, but you kind of can just say, hey, use Jupyter as a backend to render all these plots, for example. And it'll just use Jupyter as a backend. Yeah.
Nice.
Yeah.
Yeah, thank you, Alex. So you mentioned Jupyter Hub. So could you please tell a little bit? So basically, what? Because I think you've mentioned it several times, like in our private discussions, and I was wondering. So basically, what's Jupyter Hub?
Basically, it's pretty great, right? It's something that is, God, I think it's gone through some sort of containerization, probably Kubernetes or whatever. So it's basically a virtual machine wrapped up, and that's served through our on-site cloud. We need special permission if we have to work in the cloud because of European data protection regulations. We have like a cluster that's separate on site, and it's basically, there's a simple queuing system and basically users that through web interface request a virtual machine of certain size, certain number of cores, certain amount of RAM, and then it opens up. It has a couple of commands to mount like various disks you can use, either from main cluster or from your sort of whatever other disks. For storage, it defaults to like 100 gig storage. It has Jupyter Engine installed. It has RStudio installed. It has, several. We have several like Dockers or whatever other containers, basically preset for some laboratories who do things their own way, and one generic one. And basically I do, and because of that connectivity thing, I do all of my work now. Like you basically open it in browser, so you don't need to install anything in your laptop. You don't need to care about like which laptop you're on. It's double authentication using GitHub and our internal credentials. So it's considered fairly secure. You can probably do two-step or whatever, but Yeah, and it's the convenience of it, right? Is basically again RAM. Anything like any big object you work with, unless CVI has developed now a thing based on their TileDB, so you should be able to use regular laptop with enormous data sets and read it from the disk and not use all of the RAM. But a lot of the previous single cell analysis was all RAM. And basically, if you don't have like normal people's laptops don't have more than like 32 gigs, right? And 32 gigs will probably, that's like 200,000 cells. That's it, I think. Even in scan pipe. So anyhow, yeah. Basically, you pick your thing. It's kind of similar to a normal high performance computing, but there you usually sort of competing for like CPUs. Here, nobody cares about CPUs because especially in R, things don't parallel that well. And even in most Python things, they're not, usually it's not CPU intensive, but it's definitely RAM intensive. So yeah. And then, yeah, customizable, you usually have a sudo rights on it because nobody cares what you do on the main virtual machine. But and basically if you, after a certain period of inactivity, that thing is killed. Your instance of Jupyter Hubs, you have to restart it again. And after it's killed, your environment doesn't persist except for things you install in separate virtual environments. Our packages are stored separately and they persist. But that probably can be tuned to, depends on the setup, how the admin sets it up. It can probably be done to persist, like everything can persist. Yeah, so when then people work in their virtual environments that naturally translate in Jupyter Hub, so you activate in any environment you want, you can extract the YAML file. So for reproducibility, you can say exactly which versions of RStudio, just say versions, whatever. And that's the main environment for downstream that Sangre uses. We have our program wide that basically our team supports, but there's also Sangre wide that we're slowly sort of trying to get it off our hands, so they admin it. But it's fairly actually painless solution if you have the resources to serve that. And it's good, like shared environment, so people like, because if you start the same virtual machine as the guy next to you, you'll probably have most of pre-installed packages the same, so things that are like naturally reproducible that way. Like, yeah, obviously, if you make your own environment, there'll be a little different still.
Great, thank you. Yeah, I think we forgot to ask Roma. So Roma, I think that you probably, I guess, are in the group who said that you use like PyCharm or DataSpell or something like this. Correct me if I'm mistaken, and if not, then could you please elaborate on like basically what are the features which you like about the things you use?
Yes, now I'm using mostly DataSpell. So initially I used Jupyter Web, and I tried to install different extensions, but sometimes it's not very convenient when you update your Jupyter to new version. Normally, each time more extension became not compatible, and it was not very convenient. So as for DataSpell, it's actually a funny story because it's like in PyCharm, it's the third implementation of Jupyter notebooks, and first two were really inconvenient and unusable from my point of view. But the latest one is quite close to what we have in Jupyter Web. And as for DataSpell, I really like that it provides you standard features like you expect from Python. So for example, in Jupyter Web, there is quite good code inside support, like completion of different names, like different methods. And it uses runtime completion, and it normally works, but it doesn't work when you want to make a function and type some Python code inside of function. So when it's like not available on runtime, code inside in Jupyter Web doesn't work. And in DataSpell, they managed to bind both runtime completion and normal Python completion from PyCharm. So it looks pretty well from my point of view. And also there is documentation available, which is also convenient. And you can debug your cells in very easily in DataSpell. So I'm not sure, is it, could you debug your code in Jupyter Web? So maybe yes. And also, as for DataSpell, you could connect it to the remote Jupyter notebook, so which is running locally on a remote machine. And also, if you put your data in Git, it allows you to see a difference when you commit something. So I don't commit notebooks with tables and plots because they're extremely large. I usually just clear my notebook and then I commit it. And as for executed notebooks, I just store them in Google Drive and have a link to these executed results in the beginning of my each Jupyter notebook. So it's not ideal solution, but it's, for me, it's at least quite convenient.
Yeah, thank you. Do you have anything?
No.
Okay, yeah.
A quick question: is DataSpell like commercial now? Is it free?
I'm sorry.
I think it is
commercial, yeah. So and basically the same features should be available in commercial version of PyCharm, like PyCharm Professional. And this notebook supports, as far as I remember, it's only in commercial version. And as for DataSpell, the main difference to my mind compared to PyCharm Professional, that it has some simplified user interface because it's supposed to use for data analysis like Python and R, and not for web application design. So lots of redundant things for data analysis were cut off from PyCharm Professional, and they made this DataSpell bundle.
Yeah, I think that also DataSpell is like JetBrains products usually have like the student licenses, etc. So probably at least for some people in the community that should be free.
Yeah, and also we have some program for open source projects, so maybe it's also applicable.
Yeah. Okay. Yeah. Thank you so much for sharing this opinion. Yeah, I think that the last question which I have in the questionnaire, which was basically for today, was the question about the structuring of the notebooks. And I think that, well, people who have shown us like the demo of Quarto, I think Alona has already showed like the has like more or less nice navigation, and I think that there you have like a native way of basically organizing this in terms of these sections, etc. But generally, especially for like typical Jupyter notebooks, it's I think quite often you face an issue that you have basically like a huge amount of cells in a single Python notebook. I think the examples which I showed in the beginning. So basically, that's kind of a one analysis which I've performed at some point in time, and yeah, that's extremely long. I think that's not a good practice when you have basically a single notebook which is like has this like extreme amount of cells, and sometimes when you execute each cell like multiple times, you may very well end up with like having this numbers near like in and out exceed like 1,000. I had this I think a couple of times. So basically,
there are two things there I can mention. One is that the guy if you Google, I hate notebooks, I forget who the guy is, like he's a major data scientist, I think Joel Gruss, doesn't matter. Like basically says like you can execute cells in the wrong order. And if variables are like named not super consistently, or rather too consistently, that you'll get the result you don't expect. But the other thing is, I think notebooks are rendered at once. So if you have a notebook that's bigger in size than several tens of megabytes, which happens if you have big images, many of those, you'll just freeze. It'll kill your Jupyter. Like you will, and there is nothing you'll be able to do. Like you have to actually go inside the JSON and split it up. So here are the benefits of like sequential code, something like an R when it's just code. Like that is kind of like, opening a big file with text editor that opens the whole thing into RAM versus like less that goes like frame by frame, right? You just execute what you want when you want it. But yeah, big notebooks are an evil thing. And in this, like if you make big, complicated, heavy pictures, images inside a notebook, that's something to consider. Like you want to split them up because it will, it might not freeze your machine, but it frees somebody else's. So it's
and like
also,
what
I'd like to add that there is a Jupyter extension which allows you to collapse your notebook using Markdown headers, and
nice.
it was really nice when I use it.
do you remember the name of this?
Google it.
Yeah, sounds like Google. Sounds
yeah,
useful.
probably. Yeah, Alex, I wanted to ask you, because you were the one who said about this, like freezing, etc. So basically, what's your preferred way to do it? So basically, do you like split the analysis normally into several notebooks or not? And if yes, so what's basically your like logic when you like stop, finish the first notebook and start the second one? So do you have any like insights into like what's the good way to split the things?
I don't actually do enough downstream. So most of my development in this 2 years has been pipeline. So that the next flow and like Bosch and stuff like that. So I did some but whatever notebooks I have, they're small. It's I keep it reasonable. But yeah, I would just split it up, and it's, that's another nightmare. Like your notebook's named Untitled 78, Untitled 79, right? Yeah, no, I'm way too obsessive to let that happen. So if you have a sequential, name them 1_ what's done, then a 2_ and whatever, and then immediately you'll know what's happening there. So yeah, just split them up.
I think that's good. That's a good take. I unfortunately, I have a I personally, I've shown you the example that like an extremely large one. I usually also try to split, especially for like publication purposes. But unfortunately, I myself quite frequently I miss the moment at like point when I have to stop like basically writing the single node and start basically making two. The same as for R Markdown, basically, because I also had like R Markdown that like tens and tens of chunks in there, and I think I lack intuition as to like at what point in time do I have to basically like just split things into elements. Yeah, but I completely agree that you should probably have to do this routinely, because unfortunately, yeah, there are many issues, and as Alex mentioned, yeah, there is an issue that if you have, especially if you are unwise enough to have a variable which is named like the same name of the variable which is used for different basically data sets, different objects in the different parts of the notebook, and if you execute the cells not sequentially but in a random order depending on basically what you want to see at a particular point in time, this may lead to problems. Yeah, so that's 100% true that if you use long notebooks, you should like be 100% sure that the variable you use like is not used for other things in other places. And also, if you do some like manipulations like filtering, subsetting, etc., that you probably should use different variable names, not like overwriting the same one if it is used in some other place, especially. That's very important. Unfortunately, may lead to many bad things. Yeah, but regarding the splitting of things into pieces, so maybe if again, Elena, Roma, if you have anything to comment on this issue, yeah, then please go ahead.
So the size of my books, they goes larger and larger because when I switched to DataSpell, it didn't work well with really huge notebooks. That's why I have to split them in parts. But now DataSpell works better and better with large notebooks. So I can allow myself to be a bit more lazy. Also, I wanted to add that I noticed that if I overuse Plotly, and then my notebook really could be very slow, and even I have to make visualization. So sometimes I render Plotly just to image to PNG. To remove this interactive stuff when I don't need it. And that's allow me to make my notebooks more responsive. Also, I like to run my notebook in random order. So sometimes really it results in bugs, but I really like this flexibility that you have, that you can easily tweak something or like hack something. From time to time, I have to run my notebook from the scratch to ensure that my results are still reproducible and correct. And also DataSpell helps me with code inspections, like how white variable, if it used, for example, before it was defined in source code. So it's happens when you go something in some other part of notebook, insert some code there, which where all variables are available on runtime, and then you forget about it. Or when you forget to extract something from to the function arguments. So finally, as a recommendation, no, from my point of view, when I have too many headers, Markdown headers, like on the top level, too many chapters in my notebook, I realize that something goes wrong and I need to split it in parts.
Okay, thank you. Yeah, so is there like any additions to that from like, I don't know, do you have anything to add, or does Quarto basically solve all of your issues?
Yeah, it solved everything. So first of all, you can render, like you can memorize the rendered thing in cache. So it basically creates the folder with all the figures and with all the files, intermediate files, and you can do like the endless quarto, which is very bad. But this is very like if it renders more than 15 minutes, then I create another quarto file. But for me, I try to do the all analysis if it's like, I don't know, the step-by-step in one file. But in this project, for example, I studied the pattern of expression of neural progenitors in different frog stages. So I used like tadpole, froglets, like some of the like developing frog. And I used each Markdown file for each stage. So it basically was all the same, but then when I compared them, I created a different one. So I have like, I don't know, 6 quarto files. And I think it's okay to do several like stages in one Markdown, but if it's not too big, and if it renders for like, I don't know, 1 hour, probably you should split to like several files.
Yeah, that sounds reasonable. I should say. I think I found, so Roma, if you could look at a little bit of that. So is this like what you were talking about? So I think it's like NB extensions and something like this, like called
Yeah,
collapsible.
looks like that. Mhm.
Yeah, so that seems that's it. Okay, yeah. So just this, just to like close this topic. Yeah, thank you so much for the opinions. I think I have one last question, which I basically would like to ask to people in the experts. So regarding the like code documentation and the amount of text in your like markdowns, notebooks, etc. So basically, so how much text do you think is appropriate? So do you basically like comment on like extensively on each chunk, or only like in specific places which you find like important? Basically, what's your attitude to this? Because I personally find it so I try to split like basically things into chunks according to the logic, but sometimes I really like skip the descriptive part, and sometimes it's not basically like I don't have any like amount of text which I could add there. So yeah, my question is, so basically, what's your opinion? So how much text should you add to notebooks to make them readable?
I can give you a negative example.
Okay.
Most notebooks I usually copies of something I did before because I'm too lazy to start from scratch. And that's like a horror story because all the comments are like carried over, right? And they make no sense anymore. They have nothing to do with the code below. So this basically happens every freaking time, right? Because, you know,
And that's
yeah,
probably not a good example. Yeah, you're correct.
but it's that, well, like if you have like many notebooks that will, I mean, unless you're like good at this and you remember every single command, so you don't want like obviously for me, it's just a matter of like, if you sort of, you know, if you have the previous thing, it kind of does the same thing, right? And every single function call is there already. And then you just edit it according to like rename the variables, maybe to make so that it makes sense to like things all differently. But yeah, like I think it's easier to remove almost every single comment except for things that are unconventional. If you do this, like if you normalize, if you visualize, it's self-explanatory. A lot of notebook things, in contrast to like, I don't know, proper hardcore coding, right? I think it's fairly self-explanatory. So you can just comment on things that really require comment.
Yeah, that I think that's a good take. So Elena, do you have anything to add on this?
Yeah, and I was just looking at the file that I made. I comment every chunk, so there's like a label, yeah, thing that you can put something, and I comment even if it's obvious, because I like sometimes biologists want to see the code, and even if it's like, for me it's obvious, but I really try to put something that I did, even if like functions of a self-explanatory. It's good for people who want to like then read my code, but it's also good for me because I have a very bad memory, and sometimes I'm like a goldfish. So I really put like every comment, but I can't say that it's like the rule to do, because sometimes you like read data frame, and I put like read data frame, but because I know that somebody is going to look at it and be like, what's that? But if you're all like bioinformatician and you share things, probably it's not necessary to comment every chunk if it's really self-explanatory.
Yeah, thank you. Okay, so Roma, do you have anything to add to this or not? What's your practice?
So my notebooks are mostly for me. So that's why I usually make only minimum amount of comments, like to some maybe really non-trivial parts or some parameters which are not easy to remember them in future, why I use it. And also I really like to use Markdown headers just to introduce some structure into my notebook, and I use it mainly for navigation. So if you use Jupyter Web, you can also install table of contents notebook extension, and with table of contents you have a really nice structure view, and it's very convenient for navigation. So for example, when you run some cells, so many cells, you can even notice the progress of which cells are already executed and which are being executed at the moment in this table of contents. So there was several extensions for table of contents. I haven't tried them in recent maybe 2 years because I switched to Dataspell. But when I used web, this looks like I used before. It's really nice to have it. And if I need to share my notebook with some external people who will supposed to read and understand it, obviously I will add as much explanation as possible. And also many of notebooks I write once and do not use them in future. That's why it's not wise to spend too much time for documenting every step, because it's just one-time job.
Yeah, that's also, I think that's quite a reasonable idea. Yeah, that if you are not going to share it with anybody, and if you're not going to repeat this, that basically you probably can skip the commenting part and just do the substance. Yeah, thank you for this notebook extensions thing and table of contents. I think that might be quite useful for many folks who are here. Yeah, and having said that, I think that we should wrap up to today's discussion. I think that we are basically just 1.5 hours through, and that's basically our the time to end today's discussion. Thanks again to everyone who has participated. Thanks for the experts for joining us. And as always, the recording will be published as soon as possible. And next time, I think we'll make a little further change to the program, and we'll talk next time about cloud computing and all sorts of public and private cloud platforms for different data analysis types. I hope that we also have more people to talk on that. I am again thinking of inviting some people who are more experienced with that to share their opinions on like basically using both cloud resources for computing and as well like basically just cloud platforms for particular analysis. Yeah, thanks
Good to
everyone.
see everybody.
Yeah, thanks to everyone who participated, and yeah, and see you next time.
Thanks. Bye-bye.
Yeah, goodbye.
Bye.